The space between the stars was empty. Scientists believed so. But on July 1st, 2025, that belief evaporated. A visitor named Atlas burst from the void, and our vision of the cosmos, settled for nearly a century, was engulfed in mystery. At that moment, astronomers realized our understanding had ended. Hello, I'm Mike, the astronaut who will take you into sleep each night with cosmic hypotheses about the vast universe, based on real research, here at Deep Space Documentary. Today, we are going to explore the third confirmed interstellar object to ever visit our solar system, a traveler known as 3I Atlas. This is a story of a cosmic enigma that defies our models, flaunts a chemical signature that should be impossible, and follows a path so precise it forces us to question whether its arrival is an accident of gravity or a deliberate act of reconnaissance. Now relax on your beloved bed, breathe gently, and get ready to board the spaceship with astronaut Mike for tonight's sleep voyage. But before we take off, if you enjoy my voice, please leave me a like and subscribe to the channel. And if you can, share your time and location in the comments below so I can know where my fellow astronauts are joining me from around the world. Now, let's begin our cosmic journey. On the 1st of July, 2025, at precisely 14 hours and 37 minutes Universal Time, the quiet, clockwork universe we thought we knew received a visitor that would shatter our peace. The event did not unfold in a distant galaxy, nor in the abstract realm of academic papers, but right here in our own celestial backyard. At the Atlas Survey Station in Chile, a robotic telescope, performing its nightly, monotonous duty of scanning the skies for hazardous asteroids, captured an image of something that by all rights should not exist. It appeared as nothing more than a faint, insignificant smudge against the infinite canvas of the starfield, a single moving dot 4.5 times farther from the Sun than our Earth. But within hours, the cold, emotionless orbital calculations revealed a truth that set a shockwave through the global astronomical community. This visitor was traveling on a hyperbolic trajectory, its path a sweeping, open curve with an eccentricity far greater than 1. In the stark language of celestial mechanics, this meant it was a wanderer, unbound by our Sun's gravity. It was on a one-way trip, destined never to return. The official designation was C/2025N1 Atlas, but to the few who study the lonely travelers between the stars, it became known simply as 3I/Atlas, the third confirmed ghost from an alien star system to grace our cosmic neighborhood. Its velocity alone should have been our first warning that we were dealing with something utterly extraordinary. It was screaming through our system at 130,000 miles per hour, or 209,000 kilometers per hour. This is not merely fast by our terrestrial standards. It is the fastest solar system visitor humanity has ever recorded. To truly grasp this, imagine a rifle bullet. Now, multiply its speed by 170. That is the kinetic fury of 3I Atlas, an object carrying the momentum of a completely different star system, a place with its own sun, its own history, its own gravity. But speed, as we would soon learn, was only the beginning of its profound and unsettling mysteries. Within days, the Gemini North Telescope in Hawaii aimed its colossal 8-meter mirror toward this intruder. What it saw defied our established models of interstellar debris. Surrounding a nucleus too small and distant to see was a fuzzy, glowing coma, a vast cloud of dust and gas being actively vented into space. This was not some cold, dead piece of cosmic shrapnel. This thing was alive, breathing vapor into the vacuum as our sun's warmth awakened ancient ices that had slumbered for millions, perhaps billions of years in the absolute cold between the stars. It was a messenger that had journeyed through the galactic wilderness, surviving radiation that would sterilize worlds, and enduring temperatures that flirt with absolute zero. Yet the moment our star's light touched it, it began to sublimate, birthing a ghostly atmosphere around itself. But as the data poured in, a more disturbing pattern began to emerge, hidden within the geometry of its path. 3I Atlas wasn't just passing through, it was threading the needle between the orbits of our planets with a precision that felt less like coincidence and more like choreography. Its closest approach to Earth would be a safe 270 million kilometers, but the geometry of this passage was almost too perfect, too convenient for our observation, as if it had chosen a trajectory to ensure we would see it. Was this a natural path, a one-in-a-trillion shot governed by the impersonal laws of physics? Or were we witnessing the result of a deliberate, calculated maneuver? Imagine a probe launched from an unknown star system millennia ago, its mission to survey our sun's habitable zone. It wouldn't arrive at a random angle. It would execute a perfect gravity-assisted braking maneuver, using the planets themselves to shape its final approach. It would coast in on a path that looked natural, its engines silent, masquerading as a simple comet. Its itinerary reads like a carefully planned tour. Perihelion, its closest point to our sun, is scheduled for October 29, 2025. It will make a scorching pass between the orbits of Earth and Mars, a region of intense scientific interest. But this is where the cosmic choreography becomes almost cruel, or perhaps brilliantly tactical. As 3I Atlas makes its closest approach to the Sun, the moment of its most intense activity, Earth will be positioned on the exact opposite side of our star. For nearly 2 months, from late September to early November, our visitor will be lost in the Sun's blinding glare, completely invisible to every telescope we possess. It is as if the universe, or a guiding intelligence, conspired to hide the most important moments of this encounter. Is this a coincidence, or is it a deliberate maneuver, a craft using our own star as a shield to perform critical operations, a course correction, a deep system recharge, or perhaps the deployment of smaller, unseen instruments into the inner solar system? Before it vanishes, however, it will perform another maneuver that seems anything but random. On October 3, 2025, 3I Atlas will streak past Mars at a distance of just 29 million kilometers. That is closer than Mars' own moons get to the planet. For the fleet of robotic explorers we have placed in orbit around the red planet, this presents an unprecedented chance to photograph an interstellar object from an alien vantage point. But again, we must ask the question our scientific caution tells us to avoid. Why Mars? Of all the celestial bodies it could have approached, why did its trajectory bring it so near to the one other planet where we are actively searching for life? The one other planet adorned with our own advanced technology. Is it merely observing a barren rock? Or is it observing our observers, studying the robotic emissaries of a nascent technological civilization? The path of 3I Atlas is not just a trajectory. It is a timeline of opportunity and profound limitation, of windows opening and closing with mathematical certainty. We have marshaled our greatest instruments, from Hubble to the James Webb Space Telescope, coordinating a global effort to study a messenger from another world. Yet every day brings us closer to a final, tantalizing truth. We may not be just observing a comet. We may be being watched. When the Hubble Space Telescope, our unblinking eye in the void, first turned its gaze toward 3I Atlas on July 21, 2025, the universe sent back a paradox wrapped in starlight. The image that materialized on our screens was at once familiar and utterly alien. We saw a teardrop-shaped cocoon of dust and gas, glowing with a soft ethereal light against the infinite black. But it possessed a geometry, a presence, that no textbook on comets had ever prepared us for. The nucleus, the solid heart of this interstellar wanderer, remained stubbornly hidden, a bright, unresolved point of light buried deep within its own atmospheric shroud. Hubble's exquisite optics could only place an upper limit on its size, no more than 5.6 kilometers across. This is smaller than most cities on Earth. And yet, this tiny fragment, this relic from another star system, was generating a coma, an atmosphere that stretched for thousands upon thousands of miles in every direction. This was the first profound crack in our understanding. How could something so small create something so vast? Hubble's observation technique transformed this scientific documentation into a piece of accidental, haunting art. By tracking the comet's motion perfectly, keeping 3I Atlas centered in its view, the background stars themselves were blurred into bright, diagonal streaks. The resulting image makes the object look as though it is flying through a tunnel of light, a visual testament to its alien trajectory, its motion separating it from everything else in our cosmic neighborhood. The coma itself tells a story of physics playing out on an interstellar stage. As 3I Atlas crossed the threshold where our sun's warmth begins to boil water ice, the nucleus began shedding material that had likely been frozen for eons. Dust particles, liberated from their icy prison, formed a roughly spherical cloud around the nucleus, a cloud sculpted by the gentle, persistent pressure of sunlight into its characteristic teardrop shape. This is the classic, expected behavior of a comet, and yet the more we looked, the more the classic explanation felt insufficient. What if this shroud is not a natural byproduct of melting ice? What if it is a deliberate construction? In science fiction, advanced civilizations often employ cloaking devices or stealth technology, but such things need not be invisible energy shields. A far more effective way to hide a technological object in the cosmos would be to make it look like something natural, something common, a comet. Could this vast, glowing coma be an engineered cloud of smart dust, or a generated plasma field designed specifically to absorb radar, scatter light, and obscure the true shape and nature of the vessel within? Is it a cocoon of concealment, a shroud that mimics nature to perfection, hiding a machine of unknown purpose? The teardrop shape itself becomes suspicious under this lens. Is it really being passively sculpted by the sun, or shape the result of a field, a navigational deflector, or a dormant propulsion drive, actively shaping the flow of solar radiation and solar wind around it? It would appear to be pushed by the light, when in fact, it is commanding the light around it. Then there was the mystery of the tail. In most comets, the stream of material blown directly away from the sun is a prominent, unmissable feature. But in 3I Atlas, this feature was puzzlingly subtle, almost absent. It took until late August, with the powerful Gemini South telescope staring deep into the void, to finally confirm its presence. A faint, gossamer thread in the cosmic wind. Why was it so muted? The conventional explanation suggests we are viewing it from an odd angle, or that the dust grains are unusually large and resistant to solar pressure. But what if the explanation is more profound? What if the material being shed is not simple dust, but something more complex? Microscopic machines or filaments designed to minimize their signature, to hold a degree of cohesion, making the tail appear weak when in fact it is simply being controlled. Hubble's data held more unsettling clues. The object was brighter than it should be for its estimated size. This could mean its surface is unusually reflective, like fresh ice. But this seems unlikely for a body that has been battered by cosmic radiation for millions of years, a process that should darken and redden its surface. The other possibility is far more intriguing. What if the object is not just reflecting sunlight, but is also self-luminous? That bright, unresolved point at its heart might not be a simple nucleus. It could be the glow of an active power source, a light from within that we are misinterpreting as a reflection. Furthermore, Hubble's images hinted at complex structures within the coma, subtle variations in brightness suggesting that specific regions on the nucleus were actively venting material. Are these mere geological fissures cracking under thermal stress? Or are they precisely machined ports, emitters releasing the very gases and particles that form the object's perfect disguise? We were studying a visitor through the fog of its own making, like trying to examine a lighthouse bulb while standing in its blinding beam. The shroud was perfect. It revealed just enough to confirm its strangeness, but concealed everything essential about its nature. For all our technological power, the visitor remained unknowable, a mystery dressed in starlight, enwrapped in its own luminous and perhaps artificial breath. The universe has a way of keeping us humble, of delivering puzzles so profound they force us to question everything we thought we knew. 3i Atlas was about to serve us a masterclass in cosmic humility. When the James Webb Space Telescope, humanity's most powerful infrared eye, turned its attention to the visitor on August 6, 2025, the data it sent back didn't just challenge our expectations, it shattered them. The numbers read like a transmission from another reality. The ratio of carbon dioxide to water was 8:1. Let that sink in. In our solar system, comets are overwhelmingly dominated by water. They are cosmic snowballs, sometimes called dirty snowballs, but snowballs nonetheless. A typical water to CO2 ratio might be 100:1. Even the most water-poor comets we have ever studied barely reach a ratio of 1:2. Yet here was 3i Atlas, flaunting a chemical signature so extreme, so fundamentally alien, it now occupies a category of 1. It was as if we had discovered a planet where the oceans were made not of water, but of pure carbonation. But this was only the opening act. Between August 8th and 12th, NASA's SPHEREX mission, an infrared surveyor, mapped the visitor and uncovered something that defies every known model of cometary physics. The carbon dioxide emission wasn't a tight cloud around the nucleus. Instead, it formed a colossal, ghostly sphere extending outwards for at least 348,000 kilometers, nearly 250,000 miles. To comprehend this scale, imagine the distance between the Earth and the Moon. Now, stretch that distance by another 50%. That is the size of this object's carbon dioxide envelope, a structure so vast it could swallow multiple planets. A nucleus no larger than a small city was somehow generating and sustaining a gas cloud larger than most planetary orbits. The physics simply did not add up. This strange chemistry created a scientific drama around the question of water. The Swift Observatory had detected hydroxyl radicals, the shattered remnants of water molecules broken apart by sunlight, suggesting a significant amount of water vapor. But when the more powerful Webb and SPHEREX telescopes looked, the direct water signal was strangely muted, so faint it was barely detectable. Yet, their instruments did find clear spectral fingerprints of water ice on the object's surface. The water was there, locked in solid form, but something was preventing it from turning into gas. It was as if the object had a vast reservoir of water, but was deliberately keeping it sealed away. What natural process could create a surface that vents colossal amounts of carbon dioxide while keeping its water locked in a deep freeze? This leads us to reconsider the purpose of the CO2. In nature, it is a simple volatile. In technology, however, carbon dioxide can be many things. Can be an exhaust product. A slow, steady leak of 348,000 kilometers might not be outgassing. It might be the venting of a reactor that has been running in a low-power state for millennia. Its waste products finally being purged as it reactivates near a star. The chemical signature is not a clue to its origin, but a clue to its function. It is the hum of a machine coming to life. Or perhaps the purpose is even more profound. What if the cloud is not a byproduct, but the entire point? Imagine trying to send a message across the vast, noisy emptiness of interstellar space. You could use radio, but it degrades over distance and requires a receiver to be listening at the right time. Or you could create a signal that any civilization advanced enough to practice astronomy could not possibly miss. You could create a massive, impossibly pure sphere of a common atmospheric gas, a chemical beacon that screams, "I am not natural." The chemical recipe of 3I Atlas is so bizarre, so far outside the bounds of what we see in our own system, that it forces us to look closer. It is a cosmic hello written in the universal language of spectroscopy. This brings us to the most unsettling possibility of all. Carbon dioxide is a primary greenhouse gas, a key component in shaping a planet's climate. Could this object be an automated terraforming vessel, a cedar probe, carrying the chemical precursors for a specific type of atmosphere? Is this massive release of CO2 a test run, a preliminary deployment to study how the gas interacts with our sun's radiation before it reaches a potential target world? The unanswered questions only deepen the mystery. Its size is still a guess, somewhere between a large building and a small town. Its rotation remains unknown, as it shows no regular flickering in its brightness. A natural object tumbles, but this visitor's light is unnervingly stable. And all the while, it holds its water in reserve, like a canteen saved for the most arduous part of a long journey. The recipe of 3I Atlas doesn't just suggest an origin in an alien star system. It suggests a purpose. It is a formula for something, and we, adrift in our own cosmic ocean, have no idea what it is designed to create. The cosmos does not issue passports, but if it did, the credentials for 3I Atlas would be stamped with the emblem of an unknown and distant star. To understand what makes an object truly interstellar, we must look to the language of orbital mechanics, where numbers tell epic stories of cosmic wandering. Any object with an orbital eccentricity greater than 1 is unbound from our Sun, following a hyperbolic path that opens into infinity rather than closing into a predictable ellipse. 3I Atlas has an eccentricity of 1.7. It is not just unbound, it is moving with such tremendous energy that even the immense gravity of Jupiter can barely alter its course. The final proof is a measurement called V infinity, its velocity relative to our Sun if it were infinitely far away. For anything born in our solar system, this value is essentially 0. For 3I Atlas, it is a staggering 25 kilometers per second. This confirms beyond any doubt that it comes from elsewhere. These wanderers are incredibly rare. In nearly a decade of scanning the heavens, the Atlas survey has found exactly one. This isn't because space is empty, but because these objects are faint, fast, and fleeting. But our new eyes, like the upcoming Rubin Observatory, promise to transform this trickle into a flood, potentially finding dozens of new interstellar visitors every year. Until that time, We have only 3 confirmed guests, and they have personalities so distinct, so contradictory, they seem almost designed to confound us. The universe, it seems, has a peculiar sense of humor. First, in 2017 came Oumuamua. It was the cosmic equivalent of a silent assassin. It showed no visible coma, no tail, no outgassing our telescopes could detect. It was a dark, tumbling, cigar-shaped object that reflected sunlight like worn metal. Its behavior was almost aggressively inert until it began to accelerate away from the sun. The push was tiny, but it was undeniable, and it violated every known law of gravity for an object of its type. It was accelerating without an engine, moving like a comet but looking like an asteroid. Oumuamua turned physics into a mystery novel and vanished into the interstellar dark, leaving us with only questions. Then, 2 years later in 2019, Borisov arrived. This visitor was like a familiar friend, behaving exactly as a comet should. It had a bright, beautiful coma, a prominent tail, and it steadily breathed water vapor and dust into space. Here, finally, was the natural interstellar comet we had been expecting. But Borisov carried its own subtle surprise. It was venting an enormous amount of carbon monoxide, far more than any comet from our own solar system. This suggested it was born in a place far colder than the frigid outer reaches of our own Kuiper belt, perhaps in the dark disk of a dim red dwarf star. It was familiar, yet exotic. Now, 3I Atlas has arrived as the third act in this cosmic drama, and its personality seems deliberately crafted to break the pattern. Where Oumuamua was silent and Borisov spoke in carbon monoxide, Atlas screams in carbon dioxide. The progression is baffling. No gas, a cold gas, and now a temperate gas. Their shapes are just as different. Oumuamua was a bizarre needle. Borisov was a conventional sphere. Atlas appears spherical, but with a strangely muted tail and a coma so vast it defies physics. They are all interstellar visitors, yet they share almost nothing in common. Our scientists treat these as random, unrelated events, 3 lonely rocks cast out from 3 different alien solar systems that just happened to pass by our star. But what if this assumption is wrong? What if the randomness is an illusion? In intelligence work, one looks for patterns. Let us, for a moment, look at this not as astronomers, but as analysts. Consider this hypothesis. We are witnessing a deliberate 3-stage interstellar survey campaign. Stage 1. Oumuamua, the Scout. A stealth probe, small, dark, fast, and electronically silent. Its mission was to fly through the core of our system, observe our capabilities, and test our defenses, all while masquerading as an inert asteroid. Its anomalous acceleration was not outgassing. It was the signature of an advanced, low-observable propulsion system. It confirmed a technological civilization existed here and mapped our orbital assets. Mission accomplished. Stage 2. Borisov, the decoy. 2 years after the Scout confirmed our existence, a second visitor arrived. This one was designed to be seen and to appear perfectly natural. It acted just like a comet, calming our nerves. Its slightly strange chemistry could be easily explained away by a natural origin in a cold star system. Borisov's mission was to establish a baseline, to make us believe we understood what a typical interstellar comet looked like. It was a brilliant piece of misdirection, designed to lower our guard. Stage 3. Atlas, the Messenger. With the baseline for natural established, the main event arrives. This object is designed to be impossible to ignore and impossible to easily explain. It is neither a stealth probe nor a simple comet. Its colossal, impossibly pure carbon dioxide cloud is a beacon. Its surgically precise trajectory is an invitation to study it. Its bizarre chemistry is a riddle we are meant to solve. Scout, decoy, messenger. Seen in this light, the arrival of these three wanderers is not a coincidence. It is a carefully orchestrated campaign of galactic discovery, and we are the subject. The only question that remains is whether we are witnessing the work of one. The universe hides its deepest secrets in the smallest deviations from our expectations. The story of 3I Atlas, at its core, is about physics and motion, about the subtle dance of forces that could reveal profound truths about matter and technology in the space between stars. To understand the dynamics of this new visitor, we must first look to the ghost of its predecessor, Oumuamua. That first interstellar object established the template for mystery. It began accelerating away from the Sun in a way that defied our gravitational models. The effect was infinitesimal, a push no stronger than the pressure of sunlight on a grain of dust. But it was persistent, real, and confirmed by observatories across the globe. Oumuamua was accelerating like a comet, its motion suggesting jets of gas were pushing it from its sun-facing side. But here was the confounding problem. No telescope could detect any gas or dust. It was accelerating without an engine, a ghost ship being pushed by an invisible hand. In stark contrast, 3I Atlas has, so far, shown no such acceleration anomaly. Its trajectory is a perfect, smooth hyperbola, matching the predictions of gravity with exquisite precision. It is, for now, behaving itself. But this apparent normalcy is deeply misleading. Oumuamua's strange motion only became obvious as it was leaving our system. Atlas is still on its approach. More importantly, the most dynamic and powerful feature of Atlas is not a tiny, unexplainable acceleration, but a colossal, barely explainable cloud of carbon dioxide. How does a nucleus only a few kilometers across generate and sustain an active emission region that could swallow planets? The conventional physics demand either an incredibly active surface, perhaps 100 times more productive than any comet we've ever seen, or a fundamentally different mechanism. Some suggest the object is fragmenting, a collection of smaller chunks all venting gas. But Hubble's sharp eyes see no evidence of this. Others propose a complex interaction with the solar wind, where gas is ionized and electromagnetically inflated to an enormous size. But what if both of these explanations are needlessly complex? What if we're trying to explain a machine using the language of geology? Let us consider that the cloud is not a byproduct, it is the engine. As this object hurtles toward our sun, it needs a way to slow down, to brake. A rocket engine would be too crude, too obvious, but an advanced civilization might employ a far more elegant solution: a plasma brake. By releasing a specific gas, like carbon dioxide, that is easily ionized by sunlight, the object could generate a vast, electrified cloud around itself. This cloud would then interact with the sun's own magnetic field, acting like a cosmic parachute, creating a gentle but persistent drag. The object isn't just venting gas. It is deploying a magnetic sail hundreds of thousands of kilometers wide to gently brake against the star it is approaching. This would explain the cloud's impossible size and why the object's trajectory still appears perfectly gravitational. The braking force is subtle, magnificent, and so advanced it perfectly mimics a natural, if bizarre, cometary process. Taking this one step further, we must consider the theoretical pinnacle of interstellar travel, the Bussard ramjet, a starship that uses a colossal magnetic field to scoop up interstellar hydrogen as fuel for a fusion reactor. Such a machine would be the ultimate wanderer, capable of refueling as it traveled. The massive CO2 cloud we observe could be a secondary system, a coolant being vented, or a purge of waste material from the primary reactor, which is now coming online as it enters a resource-rich star system. It is not just braking, it could be preparing to refuel. This hypothesis solves another profound dynamical puzzle, the object's rotation. A small body venting such enormous quantities of gas should be tumbling chaotically. The jets of vapor would act like tiny, misaligned rocket engines, sending it spinning unpredictably through space. Yet the light from 3I Atlas is remarkably stable, showing none of the periodic flickering that would indicate a tumble. To a physicist, this is a deep contradiction. But to an engineer, it is a sign of design. A natural rock tumbles. A controlled spacecraft does not. Its unnerving stability is not a mystery. It is evidence of active attitude control. It is using internal gyroscopes or micro-thrusters to maintain a fixed orientation, ensuring its instruments, its sensors, or perhaps its magnetic plasma sail are all perfectly aligned for its approach. We are haunted by the ghost of Newton, trying to explain this object with the simple laws of gravity. But 3I Atlas may be operating under a different set of laws entirely, the laws of engineering. The arrival of 3I Atlas transformed the astronomical community into a global nervous system. In an unprecedented display of coordination, humanity has marshaled every major scientific instrument at its disposal, creating the most intensive monitoring campaign in history. This is not just scientific curiosity. It is a planetary reflex, a unified vigil. We have pointed every eye we have toward the visitor. From the highest resolution imaging of the Hubble Space Telescope to the profound chemical senses of the James Webb. The Swift Observatory watches for the ultraviolet flashes of molecules being torn apart by sunlight, while the wide-eyed SphereX mission maps the ghost of its colossal carbon dioxide cloud. On the ground, the twin Gemini telescopes in Hawaii and Chile, along with dozens of others, contribute to a relentless stream of data, refining its orbit, tracking its brightness, creating a symphony of science, played across continents and orbital platforms. This frantic effort is a race against an unmovable deadline, a cosmic appointment the visitor will keep with or without our permission. On its current trajectory, 3I Atlas will reach perihelion, its closest point to the Sun, on October 29th. Just as it endures the most intense heat and light, the moment its activity should reach a climactic peak, it will disappear. From our perspective on Earth, it will pass behind the Sun, lost in its blinding glare for nearly 2 full months. This solar conjunction is one of astronomy's most maddening events. The most crucial chapter of this story will be entirely ripped out. We will miss the crescendo, left to study only the prelude and the aftermath. But we must ask a more strategic question. Is this a coincidence, or is it a tactic? To an intelligence, using a star as a shield is a brilliant maneuver. This 2-month observational blackout is the perfect opportunity for the object to perform its primary mission tasks unobserved. Will it make a course correction? Will it deploy smaller, stealthier subprobes into the inner solar system? Or will it simply use the raw, unfiltered energy of the Sun to recharge power systems that have slumbered for 1 billion years? The object that emerges from behind the Sun in December may not be the same one that went in. This maddening timeline has inspired some of the most audacious dreams in the history of space exploration, the dream of the intercept. The fundamental problem is one of energy. The visitor is moving so fast that our most powerful rockets are like children chasing a bullet. A dedicated mission, launched from Earth, is a fantasy. But what about the probes we already have in space? Proposals bordering on science fiction have been drafted. The Psyche mission will have a distant flyby. The European JUICE spacecraft could attempt long-range observations during our blackout. But the most daring plan involves NASA's Juno spacecraft, currently in orbit around Jupiter. A team of astronomers calculated that a perfectly timed engine burn could use Jupiter's colossal gravity as a slingshot, redirecting the aging probe onto a trajectory that would intercept 3I Atlas in March of 2026. This plan is more than just clever orbital mechanics. It is a desperate, heartfelt cry from humanity to get a closer look, to try and meet the visitor. It is our first, primitive attempt to reach out and touch an alien artifact. But even this, our best and most creative idea, remains a long shot, hampered by fuel limits and mission parameters. The cruel irony is that the universe has delivered a sample to our very doorstep, but it is moving too fast for our technology to catch it. We are separated not just by space, but by a chasm of technological capability. Our only hope for a closer look before it vanishes rests with our robotic outpost on Mars. On October 3rd, just before it enters the solar blackout, 3I Atlas will pass incredibly close to the red planet. From there, the Mars Reconnaissance Orbiter may be able to capture an image, a final glimpse from a different world, before the visitor cloaks itself behind the fire of our star. The timing is, once again, unsettling. It will scan our Martian assets, then immediately go dark. As we stand our global vigil, we are confronted with the humbling reality that we may be watching the work of a superior intelligence, and all we can do is watch. In the face of a mystery as profound as 3I Atlas, science follows two paths. The first is to seek an explanation within the known laws of nature, however complex. The second, more dangerous path is to question if our known laws are sufficient. The bizarre carbon dioxide chemistry of our visitor can, in theory, be explained by natural processes. Perhaps the most elegant is the carbon dioxide snowline hypothesis. In any forming solar system, there is a zone analogous to our asteroid belt, where it is too warm for water to freeze, but just cold enough for CO2 to condense into ice. An object born here would naturally be rich in carbon dioxide and poor in water. Ejected from its home system, it would carry this chemical signature across the galaxy. Another possibility is that an insulating crust of organic material, baked onto its surface by eons of cosmic radiation, is trapping a vast reservoir of water ice below, while the more volatile CO2 leaks out through cracks. Both are plausible, scientifically sound explanations that keep our understanding of the universe comfortably intact. But the data stubbornly refuses to be comfortable. The sheer scale of the CO2 cloud, the lack of a prominent tail, the stable rotation. These anomalies stretch natural explanations to their breaking point. And it is in this territory of doubt that we must consider the work of figures like Avi Loeb, the Harvard astrophysicist who insists that when faced with extraordinary data, we must be open to extraordinary possibilities. Loeb and his collaborators argue that while natural origins are possible, we must also rigorously test what he terms technological hypotheses. His analysis began by noting the visitor's impossible brightness, suggesting a nucleus far larger than Hubble's estimates, or a surface with unnatural properties. He highlights the vast CO2 coma not as a geological process, but as a scale of activity that challenges conventional physics, suggesting it might be powered by an internal energy source, the faint glow of a dormant reactor or power system. This leads to a more radical reinterpretation of the evidence. Could the reddish hue of the object be something other than the effect of radiation? Could it be the weathered patina of an ancient metallic hull, a cosmic rust accumulated over millions of years of interstellar travel? And what of its cargo? An object rich in carbon dioxide and organics, with vast quantities of water held in careful reserve, is not just a comet. It is the perfect starter kit for building an ecosystem. This is the foundation of the Genesis probe hypothesis, that 3I Atlas is an automated seeder vessel, designed to find barren worlds and initiate life or terraform them. In this scenario, the colossal release of CO2 is not an accident of its birth. It is the first stage of its primary mission. It is releasing a potent greenhouse gas, the first step in warming a target planet, preparing it for the second stage when the reserved water would be deployed. Loeb's analysis becomes most provocative when he considers the object's trajectory. Its path is almost perfectly aligned with the plane of our solar system, and it makes suspiciously close passes to Venus, Mars, and Jupiter. He calculates the odds of this occurring by chance as infinitesimally small. While this could be a cosmic coincidence, he argues that the scientific method demands we consider the alternative. That the trajectory is deliberate, a flight path optimized for observation. In this framework, the line between a natural law and an alien blueprint begins to blur. Is it more scientific to invent a series of unlikely natural events to explain its path in chemistry, or to consider the single, simpler explanation, that it is a piece of technology behaving as it was designed? This is not a conclusion. It is a hypothesis, one that must be tested. The media often distorts this approach, painting it as a certainty of alien visitation. But the core idea is a profound challenge to science itself, to remain open-minded enough to recognize a blueprint even when we have only ever known the laws of nature. As 3I Atlas continues its journey, it forces us to confront this question. Are we observing a natural marvel, or are we witnessing the arrival of a messenger whose message is written in the language of physics and engineering? Tracing the path of 3I Atlas back to its home star is a near-impossible act of cosmic forensics. After millions, perhaps billions of years adrift, its trajectory has been subtly altered by every star and gas cloud it has passed. The trail has gone cold. But hidden in its velocity, in the speed and direction of its flight, are kinematic clues that point not to a single star, but to a time before our Earth existed. Our Milky Way galaxy is not a single entity, but a collection of stellar neighborhoods. Our Sun resides in the thin disk, a relatively young, calm region, rich in the heavy elements necessary for life. Above and below this lies the thick disk, a halo of older, faster-moving stars that formed when the galaxy was young and violent. Kinematic analysis shows that 3I Atlas moves like a native of this thick disk. This means it is not just from another star, it is from another epoch. It was likely born 8 to 12 billion years ago, during a period cosmologists call cosmic noon, when star formation was at its most furious, and the universe was a much more chaotic place. This object is a relic, a survivor from the dawn of our galaxy. It has witnessed unimaginable things on its long journey. It has felt the shock waves of nearby supernovae and drifted through the glowing nurseries of newborn stars. It has survived the gravitational tides of the galactic arms and the deep abiding cold of the intergalactic void. It is not merely a piece of debris, it is a silent witness to galactic history, a time capsule whose contents have been shaped by processes we can barely comprehend. What then could be the nature of a technological artifact from such a remote and violent past? If we dare to speculate, its immense age suggests possibilities far grander and more terrifying than a simple survey probe. Consider the possibility of the Ark. 8 billion years ago, a civilization of unimaginable antiquity, born in the thick disk, may have faced its end. Perhaps its star was dying, or its region of space was being sterilized by a galactic merger. In a final desperate act of self-preservation, they could have constructed a vessel to carry the seeds of their existence, their knowledge, their biology, their very essence, across the eons. 3i Atlas could be this lifeboat, a dormant ark that has wandered the galaxy for a span of time that makes all of human history seem like the blink of an eye. Its systems, powered by technologies that could last for billions of years, finally reawakening now, in the gentle warmth of a stable yellow star, to fulfill its ancient and lonely purpose. But the early galaxy was not a peaceful place. An alternative, darker possibility is that 3i Atlas is a weapon, a relic from a galactic war fought when our solar system was nothing but a cold cloud of gas and dust. It could be a planet killer, a self-repairing dreadnought cast adrift after the conflict ended, its mission parameters corrupted or lost to time. It is a ghost of war, still armed, its systems still functional, now drifting aimlessly into our quiet corner of the galaxy. Its massive carbon dioxide cloud might not be a signal or a propellant, but the venting of ancient, decaying weapon systems, or the byproducts of a damaged reactor still leaking energy after billions of years. There is a third path, one that is perhaps the most profound. If the object is a cedar probe, its age gives it a chilling significance. We know that life on Earth began relatively quickly after our planet formed. What if it had help? This object could be a Genesis probe, launched by one of the very first technological species to arise in our galaxy, a species that looked out upon a vast, sterile cosmos and decided to fill it with the potential for life. They launched thousands of these automated vessels, each a chemical factory carrying the building blocks of biology, on slow, patient journeys toward promising young stars. Their mission, operating on billion-year timescales, is still active, a final command still executing long after the civilization that issued it has turned to dust. If this were true, 3i Atlas might not just be a visitor. It could be a distant part of our own origin story, a messenger from the firstborns. We may be looking at the work of our own, most ancient and completely alien ancestors. Ark, weapon, or creator. Whatever its purpose, this echo from the galactic dawn is now here in our system, and it carries the weight of a history so deep it challenges the very foundations of our own. The approaching solar conjunction is a curtain falling on the second act of this cosmic drama. When it rises again in early December, it will trigger the most intensive, high-stakes astronomical interrogation in human history. This is the final trial. The evidence will be gathered and competing theories will face the ultimate jury, observational reality. The first test will be a spectroscopic cross-examination. If 3i Atlas is a natural object, its chemistry must obey the laws of thermodynamics. After passing through the fire of perihelion, its warmed nucleus should finally begin to sublimate its vast reserves of water ice. Our telescopes in December should see a dramatic shift in its chemical signature. The water signal should soar, and the extreme carbon dioxide ratio should begin to normalize. If this happens, the case for a natural origin will be strong. But if it emerges from behind the sun unchanged, still screaming in carbon dioxide while hoarding its water, This would defy our models and lend powerful weight to the theory that its chemistry is not natural but engineered. Next comes the photometric surveillance. High-cadence observations will monitor its brightness second by second, hour by hour. A natural comet, heated unevenly, should begin to show brightness variations as it rotates, its active jets turning toward and away from us. A lack of this variation would be deeply strange, but if the object displays flickers of light that do not correlate with its rotation or solar heating, this would be a monumental discovery. Such non-thermal emissions would be the smoking gun for artificial illumination, the lights of a machine being turned on. Simultaneously, Hubble and the world's largest ground-based telescopes will map the evolution of its coma and tail. Natural models predict a larger, more distinct tail should form after the intense heating of perihelion. If it remains muted, or if the coma changes shape in ways that defy physics, the verdict will again shift away from a natural explanation. But we have so far assumed the object of our investigation is a passive defendant. What if, after 2 months hidden behind the sun, it decides to change its testimony? We must consider the most profound possibility of all, that 3I Atlas is aware of our vigil, that its close passes of our Martian probes and its intense observation by our greatest telescopes have been noted. The solar conjunction was its chance to analyze the data it gathered on us and to make a decision. When it re-emerges, its behavior might change. Perhaps its mission of stealth complete, the vast CO2 shroud will dissipate, revealing the technological object within. Perhaps it will initiate a small but undeniably intelligent course correction. Or perhaps it will begin to broadcast a signal, a true first contact initiated on its own terms. Conversely, it could deliver a verdict far more unsettling. What if the data we get back in December is deliberately, perfectly ambiguous? Imagine its chemical ratio changes, but to a new, equally unnatural state. Imagine its brightness flickers, but in a chaotic, meaningless pattern that is neither natural nor a clear signal. This would be the ultimate power move. An intelligence so advanced it could craft a message of pure ambiguity, a puzzle with no solution. It would be a final, humbling lesson, designed not to tell us we are here, but to show us the profound and permanent limits of our own understanding. The weeks from December through March represent our last chance to hear the verdict. When 3I Atlas fades forever from our view, it will take its final secrets with it. Whether we are left with an expanded understanding of nature or the first terrifying certainty that we are not alone will be decided by the light this ghost from the galactic dawn chooses to show us in its final act. The story of 3I Atlas does not end when it fades from our telescopes. Its passage is not an isolated event. It is a prelude, the opening chapter of a new and profound era in human exploration. Its brief, baffling visit has fundamentally altered our perspective, transforming the space between the stars from an empty void into a populated realm, a cosmic ocean teeming with unseen travelers. As we struggle to understand this one visitor, we are simultaneously, almost accidentally, building the very tools we will need to study the dozens, perhaps hundreds, that will follow. Chief among these is the Vera C. Rubin Observatory in Chile. Beginning its monumental survey of the sky, its vast mirror will map the entire southern hemisphere every 3 nights with unprecedented depth. Projections estimate that Rubin will discover not one interstellar visitor every few years, but up to 70 per year. This will transform our science from telling stories about individual curiosities into a statistical census of the galactic population. We will begin to see patterns, families of objects, and chemical trends that will reveal the grand tapestry of planetary formation across the galaxy. To capitalize on this coming flood of discoveries, the European Space Agency is preparing the Comet Interceptor mission for launch in 2029. This is not a mission to a specific target, but a patient hunter waiting in the dark. It will park itself at a stable point in space, 1,000,000 miles from Earth, and it will sleep, sometimes for years, until a pristine visitor on an achievable trajectory is spotted. Then it will awaken and give chase, becoming humanity's first dedicated probe to an object from another star. We are shifting from being passive observers to active pursuers. In our effort to protect ourselves from rogue asteroids, we have inadvertently built the perfect alien detection grid. Our planetary defense network is also our first contact network. Every telescope scanning the sky for rocks that might threaten Earth is also a sentinel, watching for probes that might threaten our philosophy. Oumuamua, Borisov, and Atlas are the first objects to trip this wire. They may not be a random sampling of cosmic debris. They may be the first wave. The coming discoveries from Rubin will not just be a catalog of rocks, but a logbook of interstellar traffic. We have spent all of history on an isolated island, unaware of the vast ocean around us. Now, for the first time, we are beginning to see the ships passing in the night. The great interstellar void is not empty. It is a cosmic highway with currents and pathways connecting 1,000,000,000 stars. The objects we have seen are the first hints of this traffic. A stealthy reconnaissance craft, a natural-looking decoy, a massive industrial messenger. Soon we will see more. We will see the ruins of starships from forgotten empires, derelict vessels from ancient wars, and destination. The cosmic perspective that emerges is both humbling and inspiring. We live in a galaxy where the debris of worlds regularly crosses the void, a slow but steady exchange of matter and information that connects distant solar systems. 3i/Atlas is just one thread in this cosmic web, but by studying it, we have begun to see the intricate patterns that bind our galaxy together. The next messenger is already out there, in the dark, following its own ancient trajectory toward our sun. When it arrives, we will be ready. Our vigil has only just begun.